Astronomers confirm that a rogue Earth-sized planet is careening through our Milky Way galaxy. Earth orbits the Sun like a ship sailing in circles around its anchor, but what if someone or something cut that ship loose? Unbound from any star or solar system, what would become of a tiny world flying helplessly, heedlessly through interstellar space? Kindly support my Patreon account because YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. So, what would happen if a tiny world was flying helplessly throughout interstellar space, and what happens when a planet goes rogue like this? Scientists suspect that billions of free-floating or rogue planets may exist in the Milky Way, but so far only a handful of candidates have turned up among the 4,000 or so worlds discovered beyond our solar system. Most of these potential rogue planets appear to be enormous, measuring anywhere from 2 to 40 times the mass of Jupiter. One Jupiter is equivalent to about 300 Earth sizes. But now astronomers believe they've detected a rogue world like no other. A tiny free-floating planet, roughly the mass of our Earth, gallivanting through the gut of our Milky Way solar system. The discovery, reported October 29, just a few days ago, in the astrophysical journal Letters, may mark the smallest rogue planet ever detected, and it could help prove a long-standing cosmic theory. According to the study authors, this little world could be the first real evidence that free-floating, Earth-sized planets may be some of the most common objects in the galaxy. The odds of detecting such a low-mass object are extremely low, says lead author Premzek Mroz, postdoctoral scholar at the California Institute of Technology. This is what he explained to Live Science in an email. He says, either we were very lucky, or such objects are very common in the Milky Way. They may be as common as stars, he said. Einstein's magnifying glass. Most exoplanets in our galaxy are visible only because of their host stars. In a literal sense, stars provide the light that allows astronomers to detect and observe directly alien worlds. When a planet is too small or too distant to be seen directly, scientists can still detect it from the slight gravitational pull it exerts on its host star, called the radial velocity method, or by the flickering that occurs when a planet passes in front of the star's Earth-facing side, the transition method. Rogue planets, by definition, have no star to light their way, or to light a telescope's way to them, and instead detecting rogue planets involves a facet of Einstein's theory of general relativity known as gravitational lensing. Through this phenomenon, a planet or even more massive object acts as a cosmic magnifying glass that temporarily bends the light of objects behind it from Earth's perspective. If a massive object passes between an Earth-based observer and a distant source star, its gravity may deflect and focus light from the source. Mroz explained in his statement. He said the observer will measure a short brightening of the source star. The smaller that light-bending object is, the briefer the star's perceived brightening will be. While a planet several times the mass of Jupiter might create a brightening effect that lasts a few days, a measly planet the size of Earth will brighten the source star only for a few hours or less, the researcher said, and this exceptionally rare occurrence is called microlensing. Chances of observing microlensing are extremely slim. Mroz added in a statement, if we observed only one source star, we would have to wait almost 2 million years to see the source being microlensed. Fortunately, Mroz and his colleagues were not observing just one star for their study. They were watching hundreds of millions of stars, using observations from the optical gravitational lensing experiment, OGLE for short. A star survey based on the University of Warsaw in Poland that has turned up at least 17 exoplanets since 1992, the team stared into the center of the Milky Way looking for any signs of microlensing. In June 2016, They witnessed the shortest microlensing event ever seen. The star in question, located about 27,000 light years away in the densest part of the galaxy, brightened for just 42 minutes. Calculations showed that the offending object was not bound to any star within 8 astronomical units, an AU, or 8 times the average distance from the Earth to the Sun, suggesting it was almost certainly a tiny planet on the run, ejected from its home solar system after a brush with a much more massive object. Depending on how far away the planet is from the source, it's impossible to tell with current technology. The rogue world is likely between 1/2 and 1 Earth mass. In either case, this roaming world would be the lowest mass rogue planet ever detected. According to Morose, that's a huge milestone for the science of planet formation. Theories of planet formation have predicted that the majority of free-floating planets should be of Earth mass or smaller, but this is the first time that we could find such a low-mass planet, Morose said. It's really amazing that Einstein's theory allows us to detect any tiny piece of rock floating in the galaxy. Many more tiny pieces of rock may soon follow, study co-author Radek Poleski of the University of Warsaw told Life Science. Future planet-hunting telescopes like NASA's Nancy Grace Roman Space Telescope, slated to launch in the mid-2020s, will be much more sensitive to the galaxy's teensiest microlensing events that the nearly 30-year-old Gogol experiment is, Polowski said. If orphan planets of roughly Earth mass are indeed some of those common denizens of the galaxy, it shouldn't be long before many more of them turn up. This article was originally published on Life Science, and it's on Science Alert. Now, how do these things go running around through our galaxy? Well, it could be that they're spun off by, for example, quasars or black holes, and maybe that's a theory as to how some of our planets or even our interstellar comets are inbound towards us. I'll leave links below for you for this. It's on Science Alert by Brandon Spector, Life Science. Thank you.